Algebra students, welcome to MathABILITY Guided Practice for Lesson 9 of Algebra Essentials. We're going to be multiplying polynomials today. And don't worry, I'll explain what that means. But in MathABILITY, the goal here is to provide that extra piece of support that a lot of struggling and new math students need. Kind of like working with a tutor, only you don't have to pay a tutor. So let's get going. So I promised I would tell you what I meant when I said we were multiplying polynomials. Obviously, we know multiplying, and we've been using parentheses to talk about multiplying, and you'll definitely see that when we multiply polynomials. In fact, most often what we'll see is two larger parentheses. And inside the parentheses, you're going to see things that are adding or subtracting. We call those terms. So it could be simple, like x plus 3, or it could be a little more complicated, like 2x minus 17. But that's the idea of a polynomial. It's a group with multiple terms, more than one thing adding or subtracting. And that's what we'll be practicing multiplying today. So 4 things we'll do. First of all, we are going to review what we've already learned about simplifying, addition, subtraction, and multiplying in the land of algebra, because all of what we've learned so far is going to come up. Then we're going to mix it up, because it's one whole thing to do a skill alone, all by itself, over and over again. It's totally a different one to keep the rules straight when they're mixed up. Then we're going to compare this skill to something we did a long time ago, so that will have some context to help us understand why it works. And then finally, we're going to practice just the skill by itself for a while to help you develop that verbal script, the language to be able to prompt yourself if you get stuck or lost when you're practicing or testing. All right, let's get going. Directions on number 1 through 3 said combine like terms to simplify. Now, honestly, I didn't need to give you these directions, combine like terms. I could have just said simplify, and I would hope that you would notice, look at that, a plus sign, I'm adding. And we learned that in the land of algebra, addition and subtraction is called combining like terms, because we're only able to add and subtract the same kinds of things. So taking a look at this term, this is a t term. Its variable portion is a t. This is also a t term. They are like, I can combine them. It's kind of like I have 5 tomatoes and I put it together with 3 tomatoes. I'm going to end up with a total of 8 tomatoes. Well, if I have 5 t's and I add it together with 3 more t's, I get 8 t's. Lovely. Now, I tried number 1. Why don't you see if you can do number 2 and number 3, and then come back and join me and check your answers, and then we'll work together on number 4. Number 2, 3x plus x squared minus 6x squared plus 8x. So first term I have is an x term. And careful, x terms do not combine with x squared terms. It's not only the letter that has to be the same, it's the variable as well, if you remember. So I have 3x plus 8x. Now that's 11x. Now I have a positive x squared and a negative 6x squared. And do remember that if you don't see a number in front of a term, it's like it has a coefficient of 1. And so that's basically positive 1 minus 6. Which would give me negative 5x squared. Now you can write it like this, negative 5x squared, but be aware that it probably would be written in the opposite order on the GED. This term, the x squared term, would probably come first, negative 5x squared, and it would be in the multiple choices. So you just need to be able to recognize that your answer would be the same. And then this answer would come second, plus 11x. Notice how the signs traveled with the terms. It's not like you just flip them and keep the minus sign in the middle. And since this is written in standard form, this is probably how you'll see your answers in the multiple choice. Standard form of a polynomial. So the order to write the terms basically is with the highest exponent first. 3, 4y squared plus 9y minus 13y plus 6. I really wanted to do an example like this because we're going to see something that looks like this as part of a lot of the polynomials we multiply today. So notice that this is the only y squared term. And so nothing else will combine with it. I'm just going to have 4y squared. Now I do have, though, two plain old y terms, positive 9y and negative 13y or minus 13y. Those are like, they can combine. They're both y terms. And I highly suggest just doing 9 minus 13 in your calculator, especially if you don't have a lot of background with negative numbers. And you'll see that 9 minus 13 is negative 4. And so I'm going to write minus 4. But don't forget that when adding and subtracting, your variable portion never changes. So I'll have negative 4y. And then I have a constant term, a plain old number, and that's my only constant term. And so it will just drop. And that is my final answer, 4y squared minus 4y plus 6. Next section said multiply to simplify. We see 4 says 4n squared times n. And once again, it was nice of me to tell you guys to multiply to simplify, but I should be able to just tell you to simplify, and you can see, oh, look, this thing is shoved up against that thing with only parentheses between them. They're multiplying. That being said, remember, when you're multiplying, anything can multiply with anything else. We don't have to have like terms like we did with addition, subtraction. And the way you're going to do it is you're just going to deal with the coefficients, the numbers first. So in this case, I just have a 4, so I'll have a 4. And then you'll deal with the variables afterwards, using exponents to talk about repeated multiplication. So this is already n squared, meaning it's already 2 factors of n, or n times n is another way to think of it. And now you're multiplying in another n. So you will have 1, 2, 3 n's multiplying now, or n to the 3rd power. And that's really as hard as multiplication gets, except for don't forget that it passes out. If you have a grouping, like I do here, that has more than one term, things adding and subtracting, basically, remember that my multiplication distributes, it passes out. So my 5 is going to multiply with 7x, and my 5 is going to multiply with negative 3. Let's do it with 7x first. 5 times 7x. Well, 5 times 7 is just 35, and that x shoves up on the backside. And now we're going to do 5 times negative 3. And again, do it in your calculator if you need to, but 5 times negative 3 is negative 15. And don't forget that if terms aren't like, you can't add or subtract them. That's an x term. That's a number term. Can't do the subtraction. I'm done. You can go ahead and try number 6. Turn me back on when you're ready to check your work. And then let's make sure to do number 7 together. 6 says negative 4k times the quantity of 3k minus 19. This negative 4k is multiplying by 3k and by negative 19. Pick up your calculator, do it in your calculator, but let's deal with the coefficients first. Negative 4 times 3 is negative 12. And I already have a factor of k, and I'm going to multiply in another factor of k. K times k is k squared. Notice that when I'm multiplying, we do see the exponents change. Not when I'm adding, subtracting, but when I'm multiplying. And now let's do negative 4k times negative 19. So negative 4 times negative 19 is positive 76. And it wasn't just negative 4 I was multiplying with, it was negative 4k. So it'll be positive or plus 76k. All right. And then once again, can't do this addition. Those terms are not like. I cannot combine, cannot add or subtract unless I have like terms. This is as simple as it's going to get. Directions on this section are more generic. Now I'm just saying simplify. I'm not going to give you a hint about whether the simplification I'm asking you to do is combining like terms or multiplication or distribution. I'm just expecting you to be able to read the symbols and know when to do what. So let's mix it up a little bit. Number 7, read it to yourself. 6n plus 7n. Right there, we have an addition sign. The question is, can we do this addition? We can't always. They have to be like. Are they like? Well, they sure are. An n term and an n term. We can go ahead and combine them. 6n plus 7n is 13n. Notice I was adding, subtracting. I'm not seeing an exponent on my n. But now compare that to number 8. This time, instead of seeing 6n plus 7n, I see 6n times 7n. 6n times 7n. Now my numbers are going to multiply, but now is when I'm going to see exponents get involved, because exponents, they are used to signal repeated multiplication. So n times n is n squared. So when I'm adding, n's and n's just give me n's. But when I'm multiplying, we have to use exponents to count up the factors. We're going to see those factors of n's growing in the exponents. Awesome. Now, obviously, 9 seems to have both going on. I can see that this 6n is shoved up against the parentheses, but I can also see addition. So now I have to think about both rules. Okay. Now, in theory, I would start in the grouping. You guys know that. Order of operations says that, but I can't do that math, right? N is a n term, and 7 is a constant term. It's a plain old number. They cannot combine. I cannot do that addition. But the good news is we learned that wonderful property, the distribution property, that showed us another way to go, that we could multiply into a grouping by passing out the multiplication. So we'll do that. 6n times n. I only have one number out front, one coefficient, that's 6. And then n times n, I'm multiplying right now, so I'm going to use exponents. That's 2 n's multiplying, or 2 factors of n. And now I'll do my 6n times my positive 7. Well, 6 times positive 7 is positive 42. And I only have a single solitary n multiplying in, and so I'll write that. So I did my multiplication. I thought of my multiplication rules, but now I still see a plus sign. So think about your adding rules. Now I have 6n squared plus 42n. I can't add, right? Super important to know when you can and can't add. We can only add like terms. That's an n squared term. That's a plain old n term. They cannot combine. I am done. 6n squared plus 42n. All right, so I did 7 through 9, 10 through 15 are done similarly. Go ahead, give those a try. You can pause me, you can try them. Turn me back on whenever you need help or you want to check your work. Otherwise, join me at number 16. 10, 9r plus 7. Now, don't be the foolish student who just mushes those together. You would be wrong. That's an R term. That's a constant term, a plain old number. They're not going to combine. This is already simplified. Nothing else I can do here. Now, 11, though, I might not be able to add 9r and 7, but I sure can multiply them, right? We can multiply together anything. So 9 times 7 is 63. And to say that that 63 is multiplying with a factor of r, I just shoved the r up real close. Number 12. So yeah, looking inside that grouping, I cannot do r plus 7, but I can use that lovely distributive property to pass out the multiplication to both the terms in the grouping. So 9 times r is 9r, and 9 times positive 7 is positive, or plus 63. And once again, you're going to notice that if I couldn't add inside the grouping at the beginning, I'm not going to be able to add after I distribute either, right? I see 9r plus 63. They're not like, I'm done. That's as simple as it's going to get. 13, 3f squared plus 4f. So they don't only need to have the same variable, they need to have the same exponent on that variable to be considered like. 3f squared and 4f are not like, they cannot add. This is already simplified. 14, 3 times the quantity of f squared plus 4f. Now we have a similar problem again inside the grouping. I can't add f squared and positive 4f because they're not like. However, I can still use the distributive property to do the multiplication. So 3 times f squared is 3f squared, and 3 times positive 4f is positive 12f. And again, you're going to see, can't add, they're not like. I'm done. 15, 3f squared times 4f. Now, I might not have been able to add 3f squared and 4f, but anything can multiply, right? So we will do 3 times 4. That's 12. And then we will have some number of factors of f. We will count them up. This is already 1, 2. See that exponent 2? That's 2 factors of f. And there's another one for a total of 3 factors of f. I have 12f to the third power. For 16 through 21, I am going to ask you not to use a calculator. And the point is not to know your times tables or even to understand exactly how to do what we're going to do by hand, which is the multiplication algorithm back from elementary school. Just want to show you how similar 2-digit times 2-digit multiplication is with multiplying binomials. So 16 says 17 times 12. So if I were going to do this without a calculator, and I will stress that this is not the only way, but this is the way most commonly taught, at least in American schools. If you guys are other places in the world and you have a different method, let me know. I'd love to hear about it in the comments. But what we do is we line them up vertically, right? And then we go one digit at a time, starting with the digit down here in the ones place, and we just start passing it out. And we pass it out to every digit in the other number. So we do 2 times 7, and we say, oh, that's 14 ones, or 4 ones and a 10. So I'm going to carry that 1 over to the tens place. And then we do 2 times 1 is what we say, but really what we're doing is 2 times 10. That 1 is in the tens place, and so that's 2 times 10, which is 2 tens or 20. But I do need to account for the fact that I had a 10 from before, so I'm going to combine that in, right? I had 10, so I'm going to put in another 10. So 20 plus another 10 is 30, or 3 tens, so 3 in the tens place. And then once we were done passing out that first digit, we just moved on to the next digit and did the exact same thing, passing out again. So this is a 1 in the tens place. So basically I'm saying, when I say 1 times 7, I'm really saying 10 times 7, but 1 times 7 is 7, or another way to think of it is 10 times 7 is 70, and that's why that 7 is in the tens place. And then keep on passing that 1 out. 1 times 1 is 1, or 10 times 10 is 100, and so we see 1 in the hundreds place. And then after we did that passing out, there was a final step. We had multiplied in pieces, piece by piece. And so what did we do with the remaining pieces? Well, we added them up, right? And we did an interesting thing when we added. You know, you add your ones with your ones. So 4 is the only thing in the ones column, so it would just drop. And we added our tens with our tens. Well, 3 tens plus 7 tens is 10 tens, or no tens in 100. And then we add up our hundreds. And in this case, I would have 1, 200. And that's how I would get my final answer, 204. So what I want you to notice is 2 things. We passed out all of the digits of one number to all of the digits of the other number. We multiplied in pieces. Then we added the pieces together. But when we added, it didn't pass out. We could only add ones with ones, tens with tens, and hundreds with hundreds. Well, that basic principle, it's exactly what we're going to see in algebra. We're just organizing our work differently. Let me show you what I mean. So as we go to do today's concept, which is multiplying binomials, we are going to treat each one of those terms just like we treated digits in the last problem. 17. The quantity of x plus 7 times the quantity of x plus 2. Why am I saying the quantity? Because look at these parentheses. This whole grouping is multiplying by this whole grouping. And I'm going to start with the very first term I see in the first grouping, x, and I'm going to pass it out to every term in the second grouping. So let's try it. X times x. Remember, we are going to use exponents for repeated multiplication. So x squared means the same as 2x's multiplying. And then we'll do x times positive 2. Listen to me read it as positive 2 when I'm multiplying. So x times positive 2 is just positive 2x. And now I'm done passing out the x, but now it's time to pass out the positive 7. So positive 7 times x is positive 7x. And I got to keep passing out until that 7 is multiplied by everything in the other grouping. So positive 7 times positive 2 is positive 14. Notice what's going on between my terms. They're adding up because it's all these pieces that I multiplied together individually, but they're all adding together just like we saw in our last example. And then notice something else. Now that I'm going to add, I can only add like terms, meaning I can add x squareds with x squareds, x's with x's, and constant terms, plain old numbers with other constant terms, just like I could only add hundreds with hundreds, tens with tens, and ones with ones. So in this case, I only see like terms with the 2x and the 7x. Those are both x terms. I can combine them. So positive 2x plus 7x. Now I'm reading it as plus. Why? Because it's come time to add, subtract. So that is positive 9x. Now there's no other x squared terms. It just drops. There's no other constant terms. It just drops. And I'm done. Kind of like my answer up above was a 3-digit answer. This is a 3-term answer. I end up with some number of x squareds, some number of x's, and some number of ones. Again, just like I ended up with some number of hundreds, some number of tens, and some number of ones. Whew. Okay, I took a lot of time to explain that. What I'd like you to do is try 18 through 21 yourself. If you feel up to it, make sure that you pay attention when there's a negative sign involved. You can turn the video back on in order to check your work, or you could just join me at number 22 if you use the answer key and you see that you're right. Or of course, you can follow along with me so we can practice this language. Let's look at 18. 21 times 36. If I was going to attempt this without a calculator, again, I'd line it up vertically and I would start passing out each digit in the bottom number. So 6 times 1 is 6, and then 6 times 2 tens is 12 tens, or 120. And I know a lot of you guys, you just say 6 times 2, but that's what you're doing. You're saying 6 times 2 tens is 12 tens because that 2 is in the tens place. And now I'm going to pass out my 3. So 3 times 1, it's really 3 tens times 1 is 30, or 3 in the tens column. And then 30 times 20 is 600, or 3 tens times 2 tens is 600s. And now that I passed everything out, I can go ahead and add. And again, I add in those nice columns. It doesn't pass out. It's ones with ones, tens with tens, hundreds with hundreds. Final answer there is 756. Lovely. Let's try 19 with the binomials. The quantity of 2x plus 1 times the quantity of 3x plus 6. Again, we're just going to go term by term. Let's start with the first term and pass it out to the other grouping. So 2x times 3x. We're multiplying right now. I'm saying times. 2 times 3 is 6. And then we have more than one factor of x. We have a couple of x multiplying. We are going to write x squared, or 2x is multiplying. Now passing 2x out to positive 6. I read that as positive when I'm multiplying. I get positive 12 with an x shoved up on its backside. Right. Finish passing out the 2x. Now it's time to pass out the positive 1. Positive 1 times 3x. Well, positive 1 times 3 is just positive 3, and I shove an x on the backside to say it's multiplying. And now positive 1 times positive 6. Remember to read it as times and positive when you're multiplying, or you might accidentally put 7, start flipping into adding. Wasn't time to add then. But guess what? It's time to add now. 6x squared plus 12x plus 3x plus 6. This is addition. But I can only combine like terms. So there's some like terms, an x term and an x term. Positive 12x plus 3x is positive 15x. No other constant terms, it'll just drop. No other x squared terms, it'll just drop. Final answer is 6x squared plus 15x plus 6. 59 times 42. I'll line it up vertically and pass it out digit by digit. 2 times 9 is 18. That's an 8 in the ones column and a 10. 2 times 5 is 10. Well, it's really 2 times 50. It's 100. Add in another 1 up here that I carried, another 10, and then I have 11 tens. Done passing out the 2. Now it's time to pass out the 4. 4, really 40, times 9 is 36. Put the 6 down there in the tens column and carry the 3. And then 4 times 5 is 20, plus 1, 2, 3, that's 23. I multiplied in pieces, but I need to put my pieces together, so I'll add. There's only an 8 in the ones place. There are 7 tens, there are 4 hundreds, and just the 2 thousands. Now let's compare that to 21. The quantity of 6y minus 1
times the quantity of 4y plus 2. I'll start with the first term and pass it out to the next grouping. So 6y times 4y, 6 times 4 is 24, and y times y is y squared. 6y times positive 2, well, 6 times positive 2 is positive 12, and just shove a y on the backside to say it's multiplying. I'm done passing out 6y. It's time to pass out the -1 term. Listen how I say -1. I'm multiplying right now. I read that as a -1. So -1 times positive 4y will give me -4y. And again, you can do it in your calculator. Okay, this part. I know I said don't use a calculator, but I was talking about I wanted you to do the multiplication by hand so you could see how the processes were so similar. But I don't really care if you know your times tables. That is not the point of this exercise. And then passing out one more time, -1 times positive 2 is -2. Again, combine any like terms you can. There's y's and y's. So 12y minus 4y gives me positive 8y. There's no other ones. There's no other y squareds. Final answer is 24y squared plus 8y minus 2. Strong work. All right, enough reviewing, enough comparing this to stuff we've done before. Let's just practice and build our verbal script right now. So remember, the important thing is to learn this language so that you can prompt yourself if you get lost in the symbols. Here we go. 22. The quantity of x plus 6 times the quantity of x plus 5. And again, I'm saying the quantity because it's all of x plus 6 times the quantity because it's all of x plus 5 that are multiplying together. So we're going to pass out every term in the first grouping to every term in the second grouping. Let's start with the first term in the first grouping and pass that out. And I'm going to read it, say it out loud to yourself, because one of the hardest things for students here is to remember when you're multiplying versus when you're adding and subtracting. And the sets of rules, both are happening in the same problems, right? So we have to keep them straight. So this is x times x. It's multiplication that passes out. X times x is x squared. It's only when we're multiplying that we see those exponents changing. Then x times the next term is x times positive 5. Remember, we read that as positive when we're multiplying. So x times positive 5 is positive 5x. Now I finished passing out the first term in the first grouping, and now I'll pick up the next term, positive 6. I read the sign with it. That's a positive 6. Positive 6 times x is positive 6x. And positive 6 times positive 5 is positive 30. Now, what do we have going on now with the symbols? Well, let's read it. X squared plus 5x plus 6x plus 30. We're not multiplying now. We're in the land of addition subtraction, and we can only combine like terms. Anything can multiply, but addition, subtraction, that's strict. And we only see two like terms here. There's an x term and another x term. So I'll go ahead and add those. Now, listen to how I read it now. Because I'm adding, I say positive 5 plus 6. So that when I type it into my calculator, I type it with a plus sign. So positive 5 plus 6 is positive 11x. I have no other x squared terms, so it just drops. And I have no other constant terms, plain old numbers, so that just drops. And my final answer is this. This is as simplified as this is going to get. X squared plus 11x plus 30. Now, 23 through 27 are done the same way. You're welcome to try them yourself, pause me, even just check your answers in the answer key. But be careful for negatives. And of course, feel free to turn me back on if you need a step-by-step or you need help, or you just feel like you need a little more coaching of this language. Remember, it's the language I really want you to walk away with. So 23. The quantity of y minus 7 times the quantity of y plus 11. So I'm going to go term by term. I'll start with the first term in the first grouping, and I'll pass it out to every term in the second grouping. So y times y is y squared.
y times positive 11 is positive 11y. I'm done passing out the first term. Now let me pick up the second term, the next term in the grouping. I'm going to take its sign with it. When I multiply, I read that as -7. So -7 times y is -7y. And -7 times positive 11 is -77. New expression is y squared plus 11y minus 7y minus 77. I'm adding, subtracting now. I can only combine like terms. There's a y term and another y term. They can combine. Now I'm adding, subtracting. So as I put that into my calculator, I'm going to type 11 minus 7, and I will get positive 4y. Notice how I put the plus sign in front because I have a term here, y squared. If I forget that, I'll be turning the pieces that should be adding together into multiplication. And then I have a minus or -77. That's just going to drop. And again, no more like terms means there's nothing more I can do here. Final answer is y squared plus 4y minus 77. 24, the quantity of z minus 4 times the quantity of z minus 3. First term in the first grouping is z. I'm going to pass it out to every term in the second grouping. Z times z is z squared. Z times -3 is -3z. I've finished passing out z. Now it's time to move on to that next term. Next term is -4. -4 times z is -4z. And -4 times -3 is positive 12. And now look for like terms. I see a couple of z terms. Make sure you keep the sign in front of it. So that says -3z minus 4z. When I'm adding and subtracting, I read the symbols in between as plus or minus. So you can type into your calculator -3 minus 4, but you'll get -7. And -7 what? Well, I was adding and subtracting z's. Remember, when you're adding and subtracting, the variable portion stays the same. No other constant terms, 12 will drop. There were no other z squared terms that will drop. Final answer is z squared minus 7z plus 12. 25, the quantity of 2a plus 1 times the quantity of 3a plus 2. First term in the first grouping is 2a. I'm going to pass that out, distribute out the multiplication to every term in the second grouping. So 2a times 3a first. 2 times 3 is 6. And a times a. Don't forget to use exponents for repeated factors when multiplying. 2a times positive 2 is positive 4a. Now I'm done passing out the 2a, time to pass out the positive 1. Positive 1 times 3a is positive 3a. And positive 1 times positive 2 is positive 2. Look for like terms now that I'm adding and subtracting. Positive 4a plus 3a is positive 7a. There's no other constant terms, so I'll just have plus 2. There's no other a squared term, so I'll just have 6a squared. Final answer is 6a squared plus 7a plus 2. That's as much as I can do here. 26, the quantity of 4b plus 9 times the quantity of b minus 10. First term in the first grouping is going to pass out to every term in the second grouping. 4b times b is just 4. B squared, remember when you multiply, that's when we see those exponents start changing. 4b times -10. Remember when we multiply, we read that as negative. So 4b times -10 is -40b. I'm done passing out 4b. Time to pass out the next term, positive 9. Positive 9 times b is positive 9b. Positive 9 times -10 is -90. Okay, now it's all addition, subtraction, no more multiplication left. And so I can only combine like terms. -40b plus 9b, those are both b terms, they can combine. And -40 plus 9, make sure you put that negative in the calculator, is -31b.
No other constant terms, it'll drop. No other b squared terms, it'll drop.
Final answer is 4b squared minus 31b minus 90. Do you feel like a ninja yet? You're so ninja. It's the second time I'm recording this because I forgot to hit record last time, guys. So I'm getting a little punchy. Okay, 27. The quantity of 5c minus 2 times the quantity of 4c minus 13. First term in the first grouping. 5c, let's pass it out. 5c times 4c is 20. Don't forget, c times c is c squared. 5c times negative 13. Feel free to do 5 times negative 13 in your calculator, but you should get negative 65. But your calculator doesn't know that's negative 65c. You better know that we had a factor of c in there. Now I'm done passing out 5c. Time to move on to negative 2. Negative 2 times 4c, negative 8c. And negative 2 times negative 13. Do in your calculator if you need to, but a negative times a negative is a positive. It's going to be positive 26. Goodness, goodness. It's all addition and subtraction now, so look for your like terms. Negative 65 minus 8. What's that? Negative 73. And remember, when adding and subtracting, C's are C's are C's. They're not going to suddenly get exponents on them. There are no other c squared terms. This guy will just drop. No other constant terms to combine with. This guy will just drop. Final answer is 20. C squared minus 73c plus 26. Nice job. All right, you guys. Now, what do? Now is when you do the beginning level practice. Want you to try that independent practice to make sure that this all sticks for you. Use the solution videos if you need them. Don't just go, oh, I got a wrong answer. There's the right answer. If you get a wrong answer, go right away and check out the video. Make sure you know how to correct it so that on all the problems after that, you can get them right. It's not cheating. It's smart studying. And then use this language with yourself. This script we've been developing, use it. Read these problems as the quantity of something plus something, or the quantity of something minus something times the quantity of. Use that language. Signal to yourself verbally that you're multiplying with a group. And then say to yourself, you know, what's the first term? Okay, this first term of x, or this first term of 2y, or this first term of 3k, it's going to multiply with every term in the second grouping. And then as you do it, tell yourself, x times x, x times 5. Say it so you know what you're doing. And then once you finish your multiplication, make sure you know, okay, now I'm in the land of addition and subtraction. Now the rules just got strict. I can only combine like terms. And then finally, of course, know when you're done. If there's no more you can do, there's no more you can do. Go home, drink some tea. You're done. All right. Okay, you guys, I'm so proud of you. You're doing great work. You really are. You're becoming algebra ninjas. You're going to be prepped for the GED test. You're going to be prepped for college. Mama Kate's going to be so proud. I'm feeling emotional today. I might cry a little bit just thinking about it. All right. Super proud of you guys. Happy learning.